Project management already.
I never ever pen in my purse, but I have like 10 markers in my bag.
I've got, yeah, I don't know where I could. Of course, a lot of them, since I don't use them all that often, I guess, they're not working. Yeah.
Like, yeah, as long as somebody else is like walking up, it's good.
Are they priced?
You can get, if you want to get a little bit better performance out of the service, there's a couple different models, but it's really good.
Yeah. You ever seen some TV as well? In the market again now. You're just placing TV, you got fried.
Oh yeah, you did.
Well, it did, you know, at first when I first snapped it, 12 hours on 9K, but come to find out, it's just a surge because of the light. And so the firefighters had to actually put the hole, they dug that hole in there because there was an attic fire caused by the, I guess, who knows which one, because underneath the air handler, there was. Yeah. So anyway, and then we're finding like different electronics are having some problems, and so getting somebody to say, okay.
When we were in Albany meeting, Ethan kept saying, hey, this means, oh, it's like this, like people, fires is no object, it's about this,
Oh, wow.
oh, so we can get back to the pros, right?
Don't get it. But if we don't why not? I mean, these airs are just ridiculous for, you know.
I'm not doing any VM, so it doesn't say.
Really? You're not? Yeah, I'm running a VM for my database, Elasticsearch. We got like those on Redis. All three of those are running on VM. I'm not gonna go back to the Docker thing like I did the other day. That's all running just some integration testing and stuff. I haven't had time to do that part yet. We're working, trying to work on these tests right now.
Texas is kind of halfway between those two.
Like your project? What's that?
I told my boss and said that it's not going well.
Really?
Node is not great for this. What we're trying to do. So none of this would be the just like done this before. Like about bus systems like Kafka, Veg. So Ethan just wants to database. So you want to run a record node to send things to Kafka or to have in queue, which what I think now is that we don't need nodes. We just send stuff directly to Kafka or everything. We don't need a middleman. Like,
I did stuff with it.
because I think we're doing too much.
So you've got something sitting in the middle that will send either, you know, Kafka or.
Yeah, so because I don't know, Ethan had this idea of doing it before they got all sites, takes out all sites. And I was like, okay. But there's nobody really, there's no
the language is gold.
Sending jobs to the great machine.
Our website.
That's when they were like send a job and yeah, I guess get the
Our
status of the
computer.
job.
Right now it's like
Our
Postgres.
Facebook account.
Written over 16 years.
That's basically it. That's the idea. It's just like managing these jobs.
If it fails, email, hey Bob, your job failed. Want to resubmit it or cancel it?
Senor.
What I should be watching to know what it is. You're not thinking about any of this? That's a good source.
Well, yeah, definitely. That's bit.com/.
That's-
Looking forward to it.
Right.
If I read you, it's him.
Yeah, that's good to know.
Right, yeah.
That's your sure.
You're a real pal, Kelsey.
Oh, wait. If it gets there.
We serve as smiling faces here. So when you need to look for smiling faces in the audience, this is guaranteed.
Yeah, yeah, exactly.
Well, this time,
Someone that went through.
Yeah, I mean, I've seen it quite a bit, yeah. But thanks for pushing me. Nice, what part? Okay. Yeah, yeah, I grew up in the suburbs originally, but I lived in like a certain part area where it's like
Like I had a mentor that I checked in with, and you know, if I really got stuck on
down here, I haven't.
they basically set up a project like,
So there's this okay. It didn't have the snap quite. It
and then
was,
they were like, okay, here's what you need to do for this step.
Up and down, like,
Come back
so I
with
just heard
either
about that one. I haven't had a chance to
results
try it yet. Round Rock's a bit far from me because I live south. But next time I'm up at IKEA, I'll give it a try.
there we go.
Yeah. Perfect.
maybe get email from. Oh, yeah, okay.
Yeah, you know, Scott kind of volunteered me to make those. So you guys dumped it, but that'd be fine. Yeah, he's fine. We all came over for it.
Oh,
Just getting those food.
Yeah, well, that's, especially, yes, but as much as I'm a new tech person and I'm realizing that I should make that nuance with like, because everybody, that's the first thing they're asking is, are you on Twitter? And I'm like, kind of, and then they're like, well, how about Facebook? I'm like, yes, I'm on Facebook. So they're like, well, I always feel like around tech people, that's where like,
and lens cells, and then everything, take everything event.
watching
There's this thing called promises, that is usually better than all that.
Yeah. I've got ideas.
Let's redeem this.
Because of
Every nail,
the research that I've done. So,
every nail.
I feel like maybe,
I have. That's framework.
No, I'm on.
Like it's fast and a year old.
So that's nice, although I'm already being like, fix these things before
You're advocating for that stuff?
yeah, it's not, I'm not the only one. There's no fighting. No, actually, Gabby is today. He was like, if you see anything like that again, just put all of the tasks in the backlog.
Right on.
It's like, okay.
Como una botella transportable
Claro. Claro, es súper práctica.
que se adapta a cualquier espacio, claro.
Me da la sensación bastante limpio, psicológico.
Internamente. Está también. Sí, pero tampoco la recargas tantas veces. No se puede abrir. No se puede abrir.
No, el networking no se puede.
Sí, sí, obvio. Sí, porque es tan fácil conseguir un huevo. Eso te iba a decir. No, claro. Hoy en día
No es que sea más fácil, pero tiene más gente laborable.
claro. Hoy en día quién está más.
Yo estoy, Ariel, Michelle, Usa y Hernán Cacho. Martín Cacho. Especialmente el equipo de ventas es ese, pero cualquiera,
I'm not studying my top.
en realidad diría cualquiera para eso. Por repente se cierra, hay conexión y todo. Eso es importante.
Igual es difícil. Mucho contacto. Por eso yo creo que este número, que soy sincero, único, no hay simplemente creo que ni ahí. Y otra, es como todo, ¿no? El problema son oportunidades pensadas. Esto es explotado y tiene que ser explotado.
Que ya les pasó antes. O sea, usar directamente.
Sí. No, es el otro.
No, por eso, pero sé que tratamos más. Que nos recomendó fue lo que había hecho. Y bueno, ex temática de ahora
Es increíble.
¿Cómo se llama la empresa?
Ah, es increíble el amor que tiene ese equipo a
Increíble, pero
bueno, sí.
tiene su participación, siempre se llama.
Steve es un poco más cipote, pero Andrew, creo que te contaba, ya es por el punto de la red de y hoy en día es un proyecto que igual el liderazgo de la parte del producto está de ese lado y Andrew solamente una vez a 2 semanas está conmigo y él es Andrew, es que está hablando de una confianza bastante grande ahí de cositas. Lo mismo. Y ahora que ya he explicado todo esto, funciona y no sé, no tengo ni idea qué hacer. Y esta villa es una de moda en Nueva York, una cosa creo que yo lo había comentado. software company así y una carta. Lo mejor que podría pasar. Sí, porque es un loco que tiene mismo show. No sé, trae un lado y dar confianza y la explicación. No,
Yeah, they used to always have money, but I think they never put much on there.
No, obvio, pero they have to do this without having to hit my phone.
La crítica que tuvo, eso lo que rescatar. La crítica que tuvo, puntual, por ejemplo, sacada de tu.
Mr. Rivers, Scott, it's not your fault.
I know, no es nombre. Si sacaron a una persona que está hablando bien, por una que no sabía hacer bien, yo vino y yo iba acá, ahora me agarró de la fría.
All right, guys. We should get started. 7:02, and I bet we'll have a full meeting. All right, this is AustinRB. Food and Tech, I think, is back in there, and Women in Code is over there. If you are in the wrong meeting. Our sponsor for the food today was O'Reilly. They kept emailing me and saying, "Hey, can you tweet this from AustinRB?" I said, "Yeah, I can. Can you sponsor our meeting?" And they're like, "Yeah, we could do that." So they're sponsoring and they're advertising the Velocity conference. It's in New York, mainly for DevOps and the operations and scaling your websites. So if you're interested in those, there's a coupon code for a discount later. We want to thank Title Factory for the space. There's Wi-Fi codes now for the Wi-Fi. My husband Nick has a stack if you need one. He's the guy over there, right there. He has the Wi-Fi codes. I have AustinRB stickers, but I think I forgot them today, so I'll bring them next time. And I bought the stickers and the meetup.com website. Yeah, I pay for that. Sometimes people help out with that, but that's mainly me and some volunteers that pay for that. I want to talk about some events in Austin. Happening tomorrow is the Dev Boot Camp. They're doing a free workshop for beginning Ruby. So I think they're going for people who don't have any programming experience yet and just want to get an introduction. So that's tomorrow night, and that's free. It starts at 6, and you can find their meetup page and sign up for that. Keep Ruby Weird conference is happening October 28th, and so far there's still tickets available. It's $200. It's downtown, and that's always a fun time, and it's like a little reunion for see all my Ruby people. Another conference in town is Node.js Interactive. Is November 29th through December 2nd, so you got a ways off for that. And I forget how much that is. I think it's costs a little bit more. I think maybe it's $450, but it's a 2 or 3 days conference. If you're into Node, that would be a good conference to go to. And happening in December is a closure conference in Austin. Usually they're on the East Coast or the West Coast, but this year it's going to be in Austin, and December 2nd and 3rd. And we're going to do a Closure Bridge workshop. Closure Bridge is like Rails Bridge, workshop for women to learn Closure. And we're going to do that at the beginning of November, so watch out for details on that. And I think they might give free tickets to all the ladies who come to the conference. I might give those to the attendees of the Closure Bridge workshop. Events outside of Austin. This is Elixir Conference. It's going to be at Walt Disney World Resorts. So see if you get your boss to pay for that one. Let me know how it goes. I'm not sure I could do that, but that is $450 and it's 2 days. So that'd be really cool for some of you that do Elixir. And here's the Velocity Conference by O'Reilly. The user group code, 20% off, is UVSRG, and it's in New York, September 19th through the 20th. We have a Slack group for AustinRB. You can ask me to add you or anybody else who's already in there. Or anyone can add anybody else. So don't add any like PHP devs because I don't think they would like it. Discounts. We have discount from O'Reilly. 40% off print books, 50% off ebooks with PCBW. And you can find this code on our meetup page and the graphic on the side. So it's a good deal there. Upcoming meetings, September is Enrique. He's going to talk about Ruby 2.4, some of the new features. And October 3rd is Elias talking about Ruby Motion. And these are all tentative, but these are our plans to for the next 2 months. So I'll need somebody maybe for November, have someone that's kind of like, maybe, and then December and January. Actually, I might skip January. I just have to see when the date falls, with like New Year's. Introductions. Say your name or your school, or if you're in a boot camp, if you're hiring or looking for work, and then tell me your favorite design pattern. If you don't know what that is, you're gonna say, I don't know. Maybe we should do a talk about design patterns. I'll start. I'm Nola. My favorite is Factory because I think it's really, really neat design pattern. Scott.
I'm Scott. I don't have a favorite design pattern, so I'll go with Factory.
Okay.
I'm Kelsey Isaacson. I work for Obsidian and I guess the builder.
That's a good one.
I'm Ashley Lewis. I work for Move It, and I don't have a favorite pattern.
I'm Conrado Viña. I work for Move It. We are always looking for work for our team. Typically recruiting. We do an apprenticeship program. The current batch starts tomorrow, so there's another one probably 2 or 3 months. And I don't have a favorite design pattern. I haven't probably.
Well, my name is Gabriel. I work for Move It as well. And if I have to choose a design pattern, maybe Singleton. Well, thank you. Yeah.
I'm Noah's husband, and I'm her boss, and she's always looking for more work because she likes to work. And my favorite design pattern is for machines.
Jesse Riggins, independent, currently working for GD right now, primarily. Doing Python though.
We'll let you stay though.
What's that?
We'll let you stay.
Exactly. There's no Python on this computer right now, right? And of course, yeah, the one that everybody loves to hate, Singleton. Why not?
James Stewart, I work for Rooster Teeth. Rooster Teeth is hiring, and I don't know if it's my favorite design pattern, but I use it a lot. Active record.
Dave Brett, also work for Rooster Teeth.
And
Whatever numbers.
Hi, Douglas Lamb, and currently looking for software dev work, and I guess the command pattern. So
we're talking design patterns. If somebody wants to volunteer, December, or January, February. Oh, okay, awesome. Here's Scott again.
What?
You just volunteered to talk about design patterns.
I'm cool with that.
Alright, our speakers today are Scott Belware, Nathan, and Kelsey. And they're gonna talk about event sourcing. And I hadn't heard that like 2 months ago, and I was like, Scott mentioned, I was like, well, what is that? I thought I knew
It's a design pattern.
what stuff was. That's kind of why I chose that question. So I was like, this is some kind of design pattern. But,
Can I change my answer?
so they're going to talk about event sourcing.
Which Apple TV is it?
Co-working.
Oh, sorry.
Thanks, Nathan.
I was just testing it out.
We're going to have an Apple TV board.
We are gonna have an Apple TV one. Alright.
If anybody need Wi-Fi cards, they changed the policy for Wi-Fi saying code. It's a one-use code. That
Yep.
says you need to the card.
Are you in Capital Factory Guest to get that, or Capital Factory?
I'm on Capital Factory, don't tell.
What's your Wi-Fi, what's the network?
I'm on Capital Factory.
Okay.
All right, as Nola said, we are talking about event sourcing. I'm guessing that Scott Belware and Nathan Ladd are probably familiar names to a lot of you. They've done a lot of meetup talks at AustinRB and other ones. I'm probably a name that's less familiar to you. This is actually my first meetup talk, and I haven't been around that long, so we'll see how this goes. But I'm a developer at Obsidian Companies, as well as Nathan. We are a financial software company focusing mostly on Mexican and Latin American banking applications. And we do a SOA or service-oriented architecture. If you haven't heard that term specifically, it's like within the same bucket as microservices, which I'm guessing most people have heard of. And we work in a Ruby stack using the Eventide framework. And the Eventide framework is something that the three of us are all contributors on, and we've largely built. And that's kind of what a part of which we're gonna talk about today. 2 years ago, I was actually working as a financial analyst at an oil company, so I'm still relatively new to development scene. In August 2014, I drove down to Austin, Texas, and started at Maker Square. And after coming out of that, I started at Obsidian Companies. I've been doing Eventide and service-oriented architecture for about 18 months now. With my background in finance and being a financial analyst and going through Maker Square, it was still a Ruby on Rails boot camp at that time. I know relational databases, and I learned relational databases, and that's kind of what I knew. Like, to me, a database was a relational database. And a lot of people here in Ruby, probably working in Rails, knowing Active Record, that's probably what a lot of people here are familiar with as well. Relational databases they make sense. They're easy. You get it. You look at a table and you can understand what's there. You have rows in the tables. Tables connect to each other. We have an order with a customer ID, so you can get everything all of the orders for a specific customer by querying the customer ID. We have unit price on product, which means we don't need unit price on order item because we can get to the product table using the product ID and get the unit price that way and doing joins and that sort of thing. So it's great for minimizing data storage, storing everything only once, and connecting it that way. And it's very easy to read. Everything that you need for a particular data object or entity is all available in the same place. It's easily accessible. It's also really great for showing current state. And hopefully you can kind of see this. If not, I'll explain it. But this is just a row in a customer table. We have a name, an email, phone number, an address, a created time, and updated time, something that we've all seen many, many times. And that's what the current state is. An entity is just, whether you look at it as a row in a database or an active record model, like that's all kind of the same thing. We use the term entity with the Eventide framework. And current state represents like what the current values of all the attributes are. So the current state of this entity, the ID is 1, the email is alex@test.com, the address is 123 Main Street in Austin, Texas. We have a created time and an updated time. So another great thing about relational databases, it's really easy to add rows, delete rows, and update rows. So if this user changes their address, we update the row. The address is now 456 Congress Avenue in Austin, Texas, and we have a new representation of current state easily available right there. The problem comes is, what if you want to know what state was at a current point in time? Like we have, this was created on July 25th. It was updated on July 31st. What if I want to know what the state was on July 28th? That information is lost with relational databases. When you update information, you replace it, the old information is gone, and you don't have it anymore. And that is one of the disadvantages of relational databases. You lose that previous information when you update or delete rows. It can also be really difficult to debug if a write happens more than once. So if you're updating an account balance and a deposit goes through and you add 100 to the balance, let's say that write goes through again, you add another 100, you don't have like an audit log of how that happened, of a way to check that or undo that information very easily. As great as it is for reading, you also have pretty slow performance for writing data. You have to lock data tables to do correct writes, and that can slow things down. And it also couples different entities or tables to each other. As we showed in the first example, you connect to the product table when you have an order item to see what the price is, but now all of a sudden, an order item query is coupled to product information. So if you change the schema of the product table, you're gonna have to update all of the queries that go through order items and everything that kind of uses that, which makes change difficult. An event database aims to work against all those disadvantages of relational databases. First of all, events are immutable. So once things are written, they're not deleted, they're not updated, they stay the way that they are. So you have a built-in audit log of everything that happened. So these events are kind of two examples to represent what I showed with the relational database. As it says, okay, the event type is new customer, and the data associated with it, we have a customer ID, a name, an email address, phone number, time, kind of the same information that you have in a relational database, just displayed slightly differently. And then rather than updating that same event, like leaving the same information here and just changing the address, you write a new event, and this event is customer moved. And this one doesn't have the email or the name or the phone number because that information isn't relevant to this event, it hasn't changed, but it does have the new address. So this way we have an audit log of absolutely everything that happened. We know when the customer moved, so we could go back and say, okay, show me everything before July 30th, and you can have a representation of state on July 30th, as opposed to just a current representation of state, which means we can reconstitute state at any given point in time. It also avoids normalization, which is data duplication. So again, going back to relational databases, if you're trying to minimize data duplication and try to reduce your storage, relational databases are great. But storage isn't as expensive as it once was, and sometimes deduplicating data isn't the best way to store it for whatever your purposes are. And that also helps avoid coupling. So you have these events. How do you get current state? That's what an entity projection aims to do. So you have those same events, and you have a class like this. Our entity is customer, and we have all of our readers here. Customer ID, name, email, phone number, address, etc. Those should probably be editor writers. But what you do is you take the entity, we do customer.new, we read that first event, and we say, okay, entity.customer.id is data of customer ID, entity.name is data of name, entity.address is data of address, etc. So you set all of the attributes on that entity, and you have an entity with state after that first event. And then you read the second event, and you say, okay, ID is the same, update the address, update the updated time, or whatever it is, and you have a new representation of current state on that entity. So that's a very basic example of entity projection and kind of the advantages and disadvantages versus relational databases. Scott's going to take over now, and he's going to go much more in depth on the entity projection.
Just a quick question. You mentioned that the events are immutable.
Yeah.
If there's a mistake in the data entry, for example.
Yeah, so that's actually kind of interesting, is if there's a mistake, whether it's data entry or a deposit that shouldn't have happened or a customer add event that shouldn't have happened, those stay in the database, and you're going to have to read them, but you can reverse it. But the nice thing about that is you also have a log of every mistake or data incorrect entry that's ever been done, and you can analyze that and see how often do those happen, how many mistakes are there. You just need to make sure that if you write an event type, then you're reversing it, you have to have a new event type for that reversal, and define that.
It's like reverting a commit and git.
Yeah.
I'm going to show the code for doing entity projections off of an event stream. I'm not really going to demo it running, because you would just see code. You wouldn't really see much. It's all back-end stuff. I could show you stuff in the database, but I'm not really sure if it would be clarifying. So we will walk through the code. There's a sort of preface. This is a pretty vast subject. I'm going to talk about projections and entities and events, commands. Nathan's going to talk about autonomous services. This subject, event sourcing, touches on. We're going to use a frame, autonomous services, because microservices is basically SOA, and SOA doesn't necessarily have the same constraints as autonomous services, but they're all common. So you get into changing the event storage model, the different compute model, and a different way of distributing your system around autonomous services. There's only so much we can talk about. This is probably something we could cover really well in 3 hours, but not within an hour. What I would like to add to that is, if you guys are interested in going further with this style of architecture and want to go a little bit deeper into code, then we can do like a special interest group meetup or coffee or something like that under AustinRB, and like split out like a study group or something if anybody's interested in doing that. So please, I know you're all gonna just want to like do this immediately, obviously, because it's awesome. So let me know what's a good time to meet and what your company's budget is, and we can totally make all this happen for you. So event sourcing is a pattern, ORM is a pattern, active record is a pattern, a class is a pattern, an object is a pattern, all these things that are inevitably, you can speak at a meta level are patterns. Event sourcing is a pattern. ORM is a pattern. I find the question, what's your favorite pattern, really, really cool, really telling. Because if you think about like ORM as your favorite pattern, but you've never done anything else but ORM, it's not exactly your favorite. It's just kind of the thing you know. You call it your favorite, that's fair enough, but let's not forget that there's the other architecture. And the other architecture is event streaming. And there's two default architectures. In the web world, since 2005, the default has become ORM, and we had a massive influx of developers constantly churning at the same time. So ORM is kind of locked in, and it's been made concrete. But it's not the way. It's, in fact, and like Kelsey was saying, it seems really natural to do this in tables. That's what you kind of think about on the back of a napkin drawing. It seems natural. It's probably the most unnatural way to do software development that you can come up with, because it completely ignores the fact of what's really happening with software, which is you have inputs, process, and outputs. You've got commands coming in. You've got something that you're doing, and then you're computing an output. What we tend to do with ORM is take in a command, and you have a command. So let's talk about a command. A command, let's just say for the sake of argument, everyone's probably done web apps. A command is analogous to like a form post, like from one of your web forms. Create customer is a command. It's just not reified in something like Rails. It's sort of just thrown away. You get the command, you get it into the controller, you bind that to some sort of model object, which is another pattern. At large in the software world, it's called an entity. In Rails, we have a sort of specialized name for it as model object or model, but it's an entity. And we sort of dispense with, we change the state of the entity, and then we save it. We throw away why it happened and what the exact results are of it. We just save current state, which is really, really convenient when you've got a framework, when you're using a relational database and you've got an ORM. And I'm a big fan of ORM as well. It's just that there's some pretty significant downsides to ORM. And it really has to do with the things that Kelsey was saying. You lose what actually the system is doing and how it happens. You're really kind of stuck when it comes time to create a autonomous services architecture, because you end up with a problem called the canonical model problem, which is diametrically contradictory to distributed services. So if you do ORM and you want to do distributed services, you're probably going to have a hell of a time getting there. You can see that in the keynote that DHH gave, talking about the majestic monolith, and this is really hard. So a lot of people are saying we've tried microservices, but we just went back and we said the monolith was great. That's not actually because somebody was trying to do microservices. It's probably because somebody tried to do a distributed monolith, and that's focused around ORM, and that's a much more esoteric topic to get into. But ORM will take you into the monolith. That's the cause of the monolith. Coupling between model objects and putting all of the information about some sort of entity in a single row is the cause of monoliths. And that is the single greatest cause for not being able to get one large, massive app that is making the team go dog slow. That's the cause of that not being able to be broken into a monolith. And when you try it, you tend to get a distributed monolith, which is basically a monolith that runs 10 to 100 times slower, because you've introduced network queries to get at different objects. What I would propose as something to consider is whether this natural thing that seems so natural is only natural because it's the thing that we're most exposed to. What is natural about it is an entity. And so here's an example app that's kind of like a flight reservation system. It's a really, really naive implementation, though. If you guys challenge this on the basis of technical implementation, it's not going to stand up. It's really a naive implementation. But the point is we don't ever get away from entities. Whether you're doing ORM or whether you're doing event sourcing or anything else, software tends to usually work around data structures or entities or representations. What we don't have here is something that's mapped to a row. So let's talk about the flight reservation world. Let's talk about event sourcing. And at the same time, we'll inevitably talk about distributed services, or SOA, microservices, autonomous services, or the anti-monolith. These systems tend to work by inbound commands and outbound events. So you get a command that comes in, you do some work, you figure out what the result of that work is, and you write the result in event, not changing the row in a database. Just writing another event. So, real quick walkthrough. There's two commands in this system. This system can do two things. It can schedule a flight, which really means just make it available for booking, and reserve a seat. And this is Southwest Airlines. There's no reserved seat numbers. There's 200 seats available, and you might get one if you're quick enough. Or you're buying tickets for a concert and you're hovering over the Moody Theater's submit button, waiting to get that ticket. But there's a certain number of them, and let's say it's general admission, non-assigned seating. So, in schedule a flight, that looks like a data structure, right? It's just a message. You could turn this into 2H this and turn it to JSON. It's just the data of that operation. You could think of this as well as a form post. If you had this in a web browser and you had a form that had all this information, you'd submit it and send that to the server, and that's a command. Right? There's two things in software systems. There's commands and queries. Everything else is a derivative of that. So in this case, we're talking only about the commands. The result of a command is an event, and they're kind of bookended. So here's the schedule flight command. As a result of that, so as a result of the schedule flight inbound command, this event is constructed. It's practically the same information. You saw this in Kelsey's example of the customer data. What we didn't see there, what we were seeing there was an event. This is the event side of things. Right, and this is the command. There's only really one field of difference here. When a flight gets created, scheduled, we're not going to say created. When the flight gets scheduled, it gets a flight ID. That's it. That's the difference. We could have taken these things and put them in a base class and save some space and save some typing, but this stuff is sort of like duplicated for the sake of the example. All right, the other command to reserve a flight, to reserve a seat. When that gets processed, pretty simple. The command for flight ID, a customer ID, timestamp, everything is timestamped. The output of that is an event. Yes, it was reserved. So these are really naive. There's not a lot of computation happening here. It's just inbound commands, outbound events. The difference in all of this, and that's as simple as it is. You get a command, you write an event. You don't get a command. Think of your active record handlers, Rails handlers. Handlers? Controllers. Right. It's been a while. Think of your Rails controllers. They take in a command, that's the HTTP, that's the params, the HTTP form post data, and you pull up a row from a database, you bind the params to the database, make the changes, do some logic, and then save the data back. In this case, we're not pulling up rows and making changes to current state. We're just saying, from current state, we're just going to write what the effect is, just the effects. So our storage is only events and commands. That's it. Actually, you don't even need to store the commands. You really need to store the commands if you want to make sure that something happens. Like when you're moving money around, you can't just do that over HTTP because HTTP is constructed so that it can fail, right? So when you want guaranteed delivery of something, you do something more than HTTP. If it's a log message or something, or some message going off to send to send a page to DevOps people, like maybe you go over a weaker protocol because it doesn't matter if it gets there. If it matters if it gets there, you save the commands. The real important thing that we save is events. And there's only events being saved. There's no other database. Which is kind of neat because we still end up here with an entity. All of our business logic still operates off of a get the entity from the store. That's very much the same model as Rails. You get an entity from storage, but it's not an entity row. And here's what that is. Kelsey sort of touched on this. Actually, I'm going to go back to. I'm going to show you what the. What the command handler looks like. This is somewhat analogous to a Rails controller. Actually, it's not analogous. A Rails controller is a message handler. It's just not called a message handler. It's called a controller because we're using the MVC, an MVC-like pattern, right? So we're taking those names out. The controller pattern is no different than a handler pattern, especially because we're dealing with messaging, especially getting an HTTP message off the wire and binding it to data objects and so forth, right? So we've got two commands that can come in, schedule, flight, and reserve. Imagine these are controllers, right? Effectively, all we do with both of these commands, because it's a very naive domain, there's not a lot of business logic, we're just creating events from them. Changing the timestamps. The only bit of logic that we really find here is right here. When we're reserving a flight, we're going to find out if a flight's sold out or not. And if it is, you can't reserve a seat. So we get the reservations every time somebody sends a reserve a seat command, a reserve command. Every time that command gets sent, this logic, somehow, somewhere, I've got this flight, right? That's one of these. And the flight has a reservation, list of reservations, and the reservations have to be, basically I've got this notion of sold out. It's if there's the number of reservations, if there's 200 seats on the plane, and the 201st person comes along to reserve a seat, if reservations count is less than the capacity, less than or equal to capacity, you can reserve a seat. Uh-huh.
I didn't know which
Saw that
direction
coming.
you were going with the other.
Yeah. Right? So if the flight is at capacity, no purchasing. So there's that, that's where that happens. Here's a command coming in to reserve a seat. We've got to check the flight is sold out. But I already said there's no row here. There's no database row. Like we've still got a flight object, and that you kind of see here. This looks a little bit like if you're used to active record. It's not active record. Here's what that means. This looks a lot like a handler, but it's a projection. And every event that can come through the system can be filtered. It can be read. And every event has, we've got this flight object, and every event has a little bit of the data that builds up what a flight is over time. In our case, it's just create the flight object and add reservations to it. Right? So that's pretty simple stuff. And effectively, all we're doing, the way the tooling works, and we're not really gonna demo this because it would just be writing debug lines. This projection object is the data access, effectively. The data access takes a store object, brand new one, an empty one, no value set, and then reads all of the events that have happened to that store, to that flight, and every time it reads an event, it sends it either through, well, it basically matches on the event type, and then affects the store. So if there's thousands and thousands of events, kind of like your bank account, you can get your balance. Your balance is the result of calculating the history of things that have happened. That's the big difference. We don't go and throw away the history of things that we happened. The history of things that happened are the application data, which is why I'm saying this is diametrically opposed to ORM, where in ORM, we're just throwing away the important stuff and keeping current state. So what we do is not care about current state and calculate it at runtime. Technically, we don't calculate it all at runtime. Imagine if you've got an account with millions and millions of, you got an entity with millions and millions of events, that's going to be pretty expensive to query because you'd be querying millions and millions of events. So we keep that in memory up to the last event ever read. And then when you get a new store.get, it effectively just reads new events, which is usually a very small subset of data. And it's one get. It's one package of data. And then we apply it.
What is going on in line 17 there? Is that like an alias?
Nathan told me not to do this because it would be confusing. Yeah. So flight is the entity, and this thing calculates up the current state of an entity. So flight is the entity, flight schedule is the inbound event. This set attributes class is just a little thing in our toolkit that basically takes one data structure and copies its attributes to another data structure. So it's like mapping. And in this case, all these fields are exactly the same between the event and the data structure, except for these. So this is basically saying map time. On the event, you'll have flight schedule.time. On the flight, you'll have flight.schedule.time. So that's kind of what all that is. It's really just an object transformation. And we don't really have that kind of stuff generically in Ruby. So this all could have been done by saying like object.field equals object.field, object.field equals object.field, and it would just been sort of like, well, it would have been tedious code. Huh?
It would have been clear.
Yes, thank you, Nathan. It would have been clear. Yeah, is that clear? And that's really all that's happening. We're taking event data, and we're moving it to entity data. And this is, like I said, it's pretty naive stuff. If you were doing a bank account or an accounting account, you'd have a transaction that is an event, and it might change the balance. So your event, your projection logic might do some calculation, right? You're basically running a current balance. So it's like, if it's a debit, you plus or minus the amount to the balance, and it's credit, it's the other way around. There's a lot of interesting side effects that come out of this. Basically, we're avoiding the canonical model, meaning this service can have a representation of the flight object, but it's not the flight object. In the company, in the software development team, there isn't one definition of flight. It could be anything, because a flight for a reservation can be a completely different data object than what a flight is for billing, or for logistics, or for maintenance, or for cancellations. But all these events might be consumed by different services. You can build up a different structure of flight from the events that are flying around the system. Those services that are interested in those particular events can listen for them and change their internal state accordingly, without actually having to have HTTP between microservices telling different services to change their state. It's just, you have an inbound command, some state changes, an event gets written, and if any service or any component gives a damn about that state change, it can subscribe to it, build up its own representation of state, and move on. That's why we're not exactly concerned with data duplication here. Storage and memory is really not our concern as much as it anymore. Denormalization of data is not exactly our concern, because we also want distributed services. And if we denormalize data, it's extremely difficult to do distributed services. I've bandied this slide around a bit, but it's a good, I'll pretend I meant to do that. It's a good representation of what the problem is. This typical product-looking active record object, or row, which seems very natural, is extremely unnatural, because it doesn't allow you to move from the monolith, which is this, all the data in one place, the data, the product. It doesn't allow you to move from this to distributed services, because this data, some of this data belongs in the catalog service, some of this data belongs in the price book service, and some of this data belongs in the inventory service. So you can't have the product. You have to have the data with the services where it belongs. And technically, there isn't necessarily an underlying database here. This might not even be the same set of companies, let alone the same software development teams. So once you go down this path of ORM, you don't have to create a canonical model, but it's really easy to sort of stop paying attention and backslide into it and get these the objects, the product, the customer, as opposed to service data. In service data, ironically, this thing looks like an entity. It's not an active record object because it's the projection of events, which means that it's the state of a process. This flight reservation is a process. Even though this looks like a flight object, a flight model, this is really just the current status of the process of booking a flight. It just so happens that if you project process data into an entity, you're going to get something that looks like active record, which means you get both the active record-ish representation in an entity, and you get the benefits of event sourcing, which means you don't throw away the reasons why data actually is the way it is. And you have the freedom at that point to remove yourself from the clutches of the canonical model problem, which frees you up to do distributed systems or autonomous systems or microservices, and allows you to contradict what DHH is saying at the keynote, that you can move into microservices. You just are going to have a hard time doing it if you see the world through the lens of your favorite pattern. So with that, I'm going to hand off to Nathan, who's going to dive in a little bit more into the issues of distributed services.
How much time do we have left?
Have till 9.
Oh, okay.
Oh, really?
How about to 8:50, so we can clear out of here, so they can go home.
Yeah, we sort of prepped a lot less than that. We thought there was going to be a kata and stuff.
No, I figured you guys would go long, so.
Could you go long? Well, so if we get to the end and we can, if this turns into a massive, I don't believe any of that crap, here's the challenge, that would also be cool. Like a Q&A
Do a
would be
panel
fantastic.
Q&A at the end. Hey, how's it going? So I want to talk about service boundaries. And the reason I want to talk about service boundaries and not just the broader topic of services is because services, and it took me a long time to get this, services are what you get when you surround code with a service boundary. And if you surround code with something that is not a service boundary, you can still call it a service, but it isn't one. So the boundary is definitely the most important aspect of microservices, service-oriented architecture, et cetera. Should I kind of do the play mode? There we
Yeah,
go.
that works better.
So really, I think that what comes up a lot, and certainly I've been doing Rails apps for a number of years, and it's every single shop that's doing Rails runs into the same kind of problem when they get to be a mid-sized team. They got a really big code base. They got a lot of different programmers that are just piling on top of commits, dealing with merge conflicts. The application becomes unwieldy. It's difficult for newcomers to come into the project and kind of get a sense of what's going on or what all is connected. Deployments get really risky. You start to have regressions. You have to ramp up your QA efforts because, you know, even a 2-line CSS fix can cause your billing system to go down. And eventually, you know, the first people that came in and set up all of that giant mess of coupling, they have so much tribal knowledge about how, you know, when this active record model gets touched, it causes this cache to be expired over here, which causes the data to be in the wrong state in that circumstance, all of that stuff. Eventually, those people with the tribal knowledge leave, and then that's when you really see that progress grinds to a screeching halt, because no one has a clue how anything works anymore. And everybody always arrives at the same general trajectory for what they want the solution to look like, and it's always, we want to break it up into some smaller things. Smaller things that we can deploy separately, smaller things that we can test separately, smaller things that can let us sort of work in one context without having to think about another. And so they reach for microservices, or they reach for, you know, engines, or extracting business logic into separate gems. You know, these are all approaches people take. And unfortunately, they almost never achieve the results that you're looking to get. You end up needing to orchestrate deployments of this service and that service together because one has a change that'll break the other. You know, examples of that kind of abound. And I think that there's a reason why that all of these service extraction efforts go very much awry. And it's because they carry, the microservices extraction process carries with it a lot of assumptions from the monolithic phase of development that don't hold true in a distributed system at all. And so you're right to be worried about microservices or service extractions. You're very likely to make a huge mess. And in fact, if you, I hate to be the bearer of bad news, but really if you think that going and building a service-oriented architecture is something that's going to be easy, it might very well prove to be the hardest thing of your career. I'm certain of it. So let's talk about what we want to get out of services. And I just sketched out a couple of these, but there's a lot more. But basically, our needs are very simple, okay? I don't want to have to spin up Foreman, which spawns like 7 different other components at the same time, so I can do active development on one piece or one component or service. That's kind of a no-no. I've worked in these environments. They're really not fun. I'd rather probably take a power drill to my temple than have to deal with Foreman again. And a corollary to that is if one of my services goes down or experiences an outage, I don't want that to cause this cascading set of failures to the rest of the services in the system. That's really important. You know, if a service is down, that might limit the availability of other things around it, but it should never cause a total system failure. And so then Netflix actually popularized something called Chaos Monkey, which is when they started building services initially, they deployed a piece of infrastructure that went around turning servers off, killing processes at random to prove that everything that went to production had to be subjected to failure so that you could not model your distributed system from the assumption that everything's always going to work, because it isn't always going to work. And I think the biggest thing as a programmer, as a designer of code, not as a machinist, but as a designer or architect, I really want to make sure that when I'm working in one problem domain, let's say the billing system, that the concerns of other parts of the application as a whole don't bleed in. I don't want to have to think about the catalog when I'm working on billing. I don't want to know. It's actually absurd to me, having worked in services for a while. It's absurd to me that when we do an order.find with active record, we'll get the order and the product and the name, and all of these properties are available to me when I'm not going to need any of them for the processing that I'm doing. But we sort of casually accept it as the way it works because we're so used to relational databases. But you really don't want to have to deal with information from other systems when you're working on one. So the key here, the missing piece of a lot of the dialogue about microservices is, the missing piece is service autonomy. And Udi Dahan is really one of the first people to really write about this. And he wrote this in 2006. I'm going to read it to you. The idea of autonomous computing has been around for some time and presents a view of the world in which computing units cooperate to achieve global goals, yet are not dependent even upon the existence of other computing units to function. And if you're envisioning tiny robots playing soccer, you're not far off, right? The idea is we have these small units that are not aware of each other's existence. When you're not aware of another service's existence, you certainly, sure as hell, are not going to need that thing running in Foreman. And when you're not aware of that thing's existence, it's certainly not going to cause you an outage when it's down, right? So this autonomy principle is actually the underpinning of being able to make services actually work. So I assembled kind of a loose definition of what I would call a service. And I would say it's an autonomous, discrete information system designed to cooperate with other services without being particularly aware of their existence. And I think that the notion of a discrete information system is really important here. Has anybody ever had to support IE6? Because you've got intranet users. So what became really popular in the 90s is these elaborate integrated systems where originally it was LDAP for the direct, you got 100,000 employees in your company and you got this directory in LDAP where everybody's username and password is. And suddenly they tacked on, because they were buying Microsoft stuff, they tacked in the Exchange server for the email. And pretty soon they threw on top of that IIS. And pretty soon you had this web server that could only serve IE6 clients that you could never upgrade without upgrading your Exchange server. Okay, because what you had was one big information system. And information systems like that are that massive and sprawling become a real hindrance. We make fun of that today, but that's exactly what most of our Rails apps are headed towards. So an information system is a software system that surrounds some context of data, like in the slide that Scott showed earlier, we had the catalog service. There's an information system around the names and descriptions of products. We had the pricing system that would allow you to understand what the price of a particular item was. And so this is kind of the big lead up here. So what I'm really wanting to describe when it comes down to designing services and service boundaries is that it's at least a two-dimensional process. Most of the time, going back to 2006 when Twitter was using Rails and they released their big API, and suddenly you could make XML or JSON formatted web requests, and you could another program could control the Twitter experience, not through the browser, right? Those of us who've been software developers outside the context of web developers, we've been dealing with APIs for decades, okay? An API is not necessarily something over the web, and it's very misunderstood. Well, anyway, we typically look at an API as being this bounded sort of context when it's not. And we typically think of, as Rails programmers, we take that conceptualization of the API, the thing that we now plug into Ember or React or whatever. We say, if I take that API server, that Git repository, that project, and I break it into lots of little ones, smaller API services that have RESTful endpoints, if you will, then I've got services. That is a very mistaken way of thinking. That's when you take the code and when you extract it into 2 or more repositories or units of deployment, you gain some advantages, but you haven't necessarily broken it up into discrete information systems. those services may very well still be reading the application state, not from the database anymore through Active Record, but instead through HTTP or REST calls. This is actually known as RP. In my view, I call it all RPC. So there's another dimension to service boundaries that's really important, which is the creation of discrete information systems. So when you have just one deployable unit and you have one kind of system of record or authority of information, you've got the monolith. This is the typical Rails app. And this is generally what people are trying to get away from when they go through services. But I think what happens is a lot of times we fixate on simply the physical extraction of code and the deployment of separate repositories, and we think that's services. But you end up with the same problem we had with RPC and SOAP, which is you build a large integrated system where you have these distributed components and all of the downsides that networked computing, distributed computing entails, with absolutely none of the benefits. These systems are still tied at the hip to one another. If one goes down, the rest go down because they can't read the state from that other service anymore. When you want to go working on one service, you got to spin all the others up in 4 minutes. The same kind of nonsense. So really, when you're going after service boundaries, you have to you have to think of a service as the marriage of a separate deployable unit and completely separate information system with its own application state that is not exposed to any other service. And that means that there's a very simple constraint and a rule that you can apply when you're designing services that's really, really handy. And that rule is that no single service boundary can allow for the information from one service to enter another service. It's very simple. You cannot query another service. You can't take the state of another service and read it and make a decision based on it. You can't even build an interface that allows for the information from one service to be surrendered. Which really, when you start to noodle on that idea in your mind, it becomes almost impossible to consider how an application might be built with that kind of rule. You can't query data at all. How are you going to build a system like this? And I'll tell you, it's very difficult until you get a house broken. You kind of have to learn how to conceive of these things in a different way. And event sourcing really makes it all work really well, because as soon as you have these this area of your technology stack called services that can't query each other, that can only tell each other what to do, then immediately you run into the problem of, I have no idea how to actually make this software present an interface. Because when you see an interface, you see all of that normalized data. You see the whole system at once. And so the need arises for what people commonly often refer to as a read model. They need some sort of database that their user interface can use to paint web pages or drive a mobile experience. And if you use event sourcing to drive your services, those events can be broadcasted and then consumed by a process outside of the service architecture that is taking all of the events from all the services and projecting them into a normalized, a third normal form, a normalized representation of all of your entities for the purpose of display, which is really pretty cool. If you try to build autonomous services without events, what you're going to have is a database replication problem. And I don't know if anybody's ever tried to get one data source of truth synchronized with another over the network, but it's a very error-prone thing to do. Event sourcing naturally uses a technique called linearization to basically model the entire history of an entity as a single linearized sequence of events where one always comes after the next, and there's a known position for where any particular consumer is at, just like a git shop or a tag or what have you. And so you can broadcast or publish your events from inside the services to an aggregated read model consumer that is able to project those into a database, which is really pretty cool how it all comes together. And I think I think that's that's about all I came up with. I didn't realize we were going to end up with a full 2 hours here. But I think that I've only scratched the surface of service architecture, service-oriented architecture, the notion of orienting your architecture around this combination of separate deployable units and discrete information systems. I can tell you that it would be hard for me to ever go back to ORM. And I loved Rails. I was like really happy. I originally came and was a firmware developer doing device drivers and stuff. And I found it really awesome when I got started with Rails to be able to build like a living, breathing application in such a short period of time. Previously, I might spend a week building enough of a bootloader to cause an LED light to turn on or off. So I appreciate the efficiency of getting started with an ORM. But having seen the disaster of services, service extractions in monoliths where you have all of these information system coupling, I don't know. I actually probably would rather just sit at home and whip myself than deal with some of those systems. And I've worked on most of the really bad Rails apps in town, so if you ever want to chat about that too, I'm down. And I've made far more messes than I've personally made far more messes than I've seen. So
let's round up. Don't have to go.
Okay.
We'll just round up by talking about where we're at with this. So this is all stuff we're doing in Ruby. Right, so this is a project that we ended up pulling out of work. When we were basically building the progenitor project of this of the framework. Let's call it. It's really a toolkit, but framework is a good enough word. Is a bank. So we build banking systems in Ruby, which isn't necessarily this isn't your 10-minute blog. The next company that adopted is another financial company that works in retirement savings through stock trading. It's a RoboCop. Not a RoboCop. That's the next one. That's coming. We really think Ruby is going to be great for the automated law enforcement robots.
Literal RoboCop.
Yeah, RoboCop. Thank you.
Donald Trump has already backordered several.
Yeah, so this is going to be huge. And the third company that we're working with also happens to be another financial company, which is a loan origination company. And it's not a coincidence that this is happening around finance companies, because most financial systems are built around event sourcing and messaging and autonomous services. But there's all kinds of stuff in these applications that don't have to deal with accounts. There's customers and logins and all the usual stuff. So we want to give you the impression that this is for your high-end banking application, which is an ironic thing to say if you're talking about Ruby anyway, because usually that goes to the Java world. But we're just saying that no, there's extremely large financial applications, and then there's everybody else, which is the majority, and they're in a host of different languages. It's just a lot easier to talk about this with financial companies because they already know the architecture, right? They're not just building the 10-minute blog in Rails. So there's things that they are already aware of that we don't have to introduce this heretical new notion of
the first general ledger was an event source system in a sense.
Yeah, pretty much. Git is a general ledger, effectively. So we've got this project. We've been working on it. It's called Eventide. It's open source. It's on GitHub. It's not documented. There's no website. There's very little sample code.
But we'll help you with any problem you have.
Right. There's the pitch, right?
I mean, all that's coming, but this stuff, you build something of this magnitude, it does take time.
Yeah. That said, we're in Austin, and we've got customers. I guess the customers now in Austin, Mexico, and 2 in Vancouver.
I think every pattern mentioned besides Active Record is at least in one place in our framework.
Yeah. So if you like patterns, So the state of this thing is we're about to do, we're in the process of doing a bunch of adaptations of the framework. We currently run on a stream-oriented database called Event Store, which is very specifically, tuned, optimized. The only thing it does is event storage. It's just a bit of a hard sell for your typical Ruby shop to run on a very special purpose database. So we're rewriting the whole thing to run on Postgres, which effectively means you could run this stuff on Heroku when we're done with changing the bottom layer of the storage. So I would completely encourage anybody and everybody to get thinking around event streaming, event storage, event sourcing. We've got tooling for it to go in Ruby. You don't have to change your programming language to Elixir, and Elixir offers none of this anyway. Elixir is, another ORM, but now you have to learn Erlang. Not have to, you should. But I'm just saying, we're taking Ruby companies that are experiencing the problems with Rails applications and fixing the root cause, which is stopping the use of canonical models and tight coupling. That has nothing to do with your programming language. You could do that in shell script if you wanted to. This has everything to do with design and architecture, topology, and the basic fundamental laws of physics and computing. So if you want to get deeper into this, we don't yet offer a whole lot of written resources, but we are absolutely willing to go anywhere at not any time, but
We'll find you in your home, in your place of work.
Yeah. We have a compound outside of Austin where we can all live together.
It's really cool. Everyone's real nice.
Yeah. No, we would actually really welcome opportunities to meet with people and talk about how you might want to try this stuff out, and even coach on implementation details and stuff. And it'll get easier over time because we'll release sample apps and documentation.
It really, the learning curve isn't terribly steep for the mechanics of actually getting up and running. There's a lot of nuances to building a whole system like this that require a lot of coaching. But I can't speak for Scott and Kelsey, but if anybody ever wants to hit me up and wants to talk about this stuff, I can help you as much. I can help you with all the things that I've learned so far. So.
And it's a real mistake to think this is high end. Like this is high end architecture astronaut, senior level developer for bank applications. That's really not the way to think about this. It's just another default architecture. The same way that Rails is a default architecture, this is just another default architecture. Anybody at any level can learn it and use it. And we use it in conjunction with Rails as well. Like you've got a Ruby app, and if there's a web interface, there's probably going to be some Rails in there. So it's not like we're rejecting 10 years of development of an HTTP stack. We're just saying that HTTP stack is not necessarily the right thing when it starts to get into ORM and Active Record, unless you're building small apps that you don't plan to turn into services. So, questions, Kelsey?
I was say I can speak to that a little bit too. I've been a professional developer for 18 months, and I'm building autonomous services by myself at my job. So it's totally doable. Admittedly, the first 3 months I was at this job, Scott was talking another language, and I needed Google Translate to understand half of what he was saying. But once you get in the context and you get,
it's just the way I talk.
kind of a quad. I think it's French. Who knows? But there's a short learning curve at the beginning. Just getting some of the terminology is a little bit different. The concepts are a little bit different, but it's doable. I do it and I really enjoy it.
So the constraint of a service does not read another, query another service. It doesn't have any online operation that locates a service and asks it for data and pulls it. That constraint will take you very, very far. It's when you apply that constraint, you're going to run into problems trying to get it to work, and that's where we can help. Let's sit down, have a cup of coffee, and figure out what you're trying to do, and then how you learn to overcome that problem and build a set of services around that constraint is really the endeavor.
And the reason people are failing with the services efforts, going from a Rails app into services, it's always the same thing. You've got a bunch of files in your model folder. Maybe you've got a product and an order and a customer, and somebody said, well, we need a product service, a customer service, and you're dead. It's over. The minute you do that, you're going to have services querying other services, and that's where DHH is giving you the right advice. Don't do it, leave it alone. If you want to build services, you can't build them around models, around entities. Entities are not the core of services. They're the core of monolithic apps. Entities are a side effect of services. The core of the service of services is events. So that's a real bummer if you're in the midst of a service transformation project that's been going on and you've tried to do it around entities. It's a natural conclusion to come from Rails and just believe that entity centricity must be the way software is written, and it's really the exception to the rule. It's rare in the world of software at large that you have these ORM style entities that are the core of the application.
Yeah, I think almost every service extraction endeavor is hard pressed to succeed.
You say the words extract a service and you don't do it and you mean it seriously, like you're not saying it as a joke, you're probably going to find in a year's time that the joke is on you. It is not actually a real thing. Service extraction is not a real feasible thing.
Yeah, if the contours of your services are shaped by the contours of your app models directory, you are headed to some place, like you're headed to some place you don't want to go.
Processes, you know, we're going to say this. I said this in my part talking about entity projection. Entities are the reflection of a business process that's unfolding, not of a data structure. So even though we had a business process called flight in the reservation system, it was just the reflection of the processes of a flight's book, seats being booked up. That's a process. It looks like a data structure, but that's only because we can project data structures off of the individual actions that are taken.
Let's take questions. I think Conrado had one.
Yeah. Great presentation, first of all. Good job. So, like from a totally abstract perspective, I'm totally sold on the advantages of event sourcing. And I definitely see the advantages when storing, like when you send the commands and you store the information. But I still didn't completely see, you mentioned at the end of your section, I'm still concerned about the performance when retrieving, when querying.
At
some instances. And that's what I didn't see in your presentation, the solution, because it seems to me like querying one entity is, since it's not all together physically in the storage.
So here's the thing, and I forgot to mention this, and I'm glad you asked that question. The thing that makes event sourcing awesome, so have you heard the adage, there's the two hard problems in programming, naming and cache expiration? So Kelsey had a slide when she went over events. Events are immutable, they can't be changed. That means that there is no cache to expire. There's no need to expire. You can cache any artifact coming out of an event sourcing database forever. So everything is trivially cacheable. And it's difficult to oversell that point. So at every layer of our stack, we have caching built in. We have snapshots. We actually have some individual entities at work that have 100,000 events in them. So you can imagine, like querying 100,000 events to play all of them through in memory to arrive at the state of the entity would be computationally infeasible. So we snapshot the entity. So every 10 or so events, we go ahead and serialize the current state of the entity, write it into the database. And so next time when the service boots up, it locates the most recent snapshot and plays forward from there.
But you're still like to Conrad's point, like you're still, if there's 10 events that have not been, when you do a get on an entity, and there's been some events that have been written, that entity is not up to date in real time.
Right.
It up-to-dates on retrieval. So it is a matter of retrieving 10 items of information rather than what you're saying, which is just that row that's already.
But you can get it in one payload over the network.
You can get it in one query.
You can query for all the events newer than this.
But then you still have to calculate the entity through the projection. So, yeah, there's a penalty.
So another way to look at it is I've seen Postgres or MySQL databases with millions and millions of rows that performed really, really well, actually. I've never seen a Rails app with active record perform with millions of rows. So I think that the reality is that an event sourcing application will have uniform performance characteristics as it grows over time. So maybe the fixed cost of fetching an entity is a little bit higher than the fixed cost of retrieving a row from a database. But that service with event sourcing is going to perform the same when it's got billions of events as it did when it first became operational.
We had tried, I'm just saying, I'm sorry, I'm introducing, I didn't even try to. We tried early on, well, we did, our original implementation kept so if you think about your entities, models, they're entities. Model is just another name for an entity for some reason. If you've got, 1 million products, well, all those products, all the ones that are queried by the app remain in memory.
Yeah, in a cache.
So we don't continually go back to disk for entities. They're in a cache, and we update them. So the ones that are cold, they probably don't get queried. The ones that are hot do. We haven't written anything yet that expires the cache or cleans the cache. We originally had an implementation that listened real time to the events and kept the cached version up to date in real time. Based on every single event, but that required a lot of multi-threaded locking and stuff like that. So we backed off on that just for the sake of simplicity. But it's a performance enhancement that is. We know how to do it. We know what's involved with it. Getting there is a matter of time, and if we ever need that kind of performance, we'll have to do it. At this point, we're running a real-time bank off the thing.
Yeah, it works pretty well. And we'll get to your question, Jesse. I'm sorry. The other thing I want to say is, when you have isolated service boundaries where each service does not share data with the rest of the system, you can improve the performance of the physical data access layer of that service in total isolation from the rest of the system. So I don't know if anybody's worked with like multi-tenancy or sharding in Rails apps, but if you want to take your orders table, because it's hit very frequently, and move it to something that you think is going to be faster like Redis, suddenly every part of the system that is traversing through the object graph created by active record that hits
and saying .order.
Yeah, that stumbles upon that order and is now broken. But with autonomous services, I can take my high transactional volume service and I can performance optimize it without affecting the rest of the system whatsoever. And we've already experienced it. It's like, it's a lot of work getting to that point, but it is amazing.
Well, I'll comment on that, I guess, to see what you guys think about it. With regard to things like, if you're doing, let's say you're going to pull a data record back that has a join in it, so you're pulling other things versus a scan of data, right? When you're doing the join, you're going to get random access, right, on your file system versus a scan, which allows, I'm assuming, an index scan. Yeah. So you're going to allow the database to get involved, the OS to prefetch, and all these other things that happen actually where you're getting a lot of benefits of cache that you're not even having to deal with, right? Because the OS, if it can predict the patterns, it's going to try to prefetch that data.
Yeah.
The database also has, especially like Postgres, has that kind of information. That's been my experience with that kind of stuff myself. I don't know what you guys think. But then a question I had was, you had that example about the flight system. I was wondering how you deal with race conditions in the case of.
We knew somebody's going to. So here's the benefits of a linearized system. If I read the state of the flight, and I ask, okay, do I have capacity? Yes, I'm going to write an event that says it's booked. I have a choice. I can either allow for overbooking, and I'll just record the event no matter what, or another option is I can ask when I get the state of the entity. I can also ask for the current version of the entity stream, and I can pass that current version in with my write, and the database underneath will ensure that my write fails if there's been events that are written to the database since I started.
So you have optimistic.
Yeah.
versioning, right?
Optimistic locking. And it works so much better than database locking, which again can't work across service boundaries the way this can.
Yeah, like there's no locking.
Yeah.
Right? There's no locking whatsoever, which to the point of the underlying operating system and a database system, that's the one thing that's going to make a system run real slow, inevitably. Especially if you get
Yeah.
two things that lock and you end up deadlocked, and then the services, and then the components of the system
Yeah.
fail and shut down.
You want to talk about performance. This is what LinkedIn and Twitter discovered. This is what led to the development of Kafka, actually. What they discovered, the computer scientists sat down and said, we've got 10 million tweets per second. What's the fastest way to get these things to disk? The fastest way is linearly sequential writes, just like a log. That's the fastest way to do it, and that's the same approach that Event Store takes.
Get it to disk.
In sequence.
Get it to disk in sequence, get it there fast, and then deal with your entity perspective as a calculation. I don't know, that's not the right word. The right word is projection. I'm afraid if we say projection, it sounds like computer science-y.
Yeah.
But it's technically a projection. It shouldn't be thought of as anything too fancy. But it really is just calculating the values of the fields of the entity, because some of those events have some of those fields, and you just kind of like cherry pick the values to construct an entity or do some math. And also, like I said, you can compose any view of that entity you want. You don't have to have like one view of flight. If you just want some values or a different data structure, subscribing to the events that have that data. And the same thing, Nathan was talking about the database that we use to display data. If you want a view of the product, but the product got all of its data all over the place, well, we will create a database with a row that you can actually see the product. But it's only read-only data. Like it's view state. The other word for that is a read model. That sounds computer science-y. It's view state. It's there to view. It's there to do reports off of. It's there to paint on the screen. It's literally display data. And you can create that display data. It doesn't have to be third normal form. That's useful. But if you wanted to denormalize it and have multiple views of that data, the way we have multiple views in the database, you just pre-compute it. So the next time you need to get a complex web page, you can get all that data in one row. Well, that's one read. And that's ultimately what is a side effect of using events. You can compose the read view of the data in any damn way you want.
And
not only that, but it doesn't have to be a relational database. You could be doing it in Cassandra or Redis. You can be writing Excel tables. You can be integrating with Google Sheets for that matter. It just doesn't matter at that
Like
point.
the things that I've seen at multiple companies tacked on top of Active Record to do reporting, like time series reporting, like the things that I've seen, the things that I've built that I'm just profusely apologizing for. All of that stuff is trivial.
It's like a truth and reconciliation session.
Yeah.
I'm sorry for the things.
I'm so sorry. When you have a log of events for all your entities.
This is where you want like a scrolling of all the names of the companies you worked at in Austin.
Oh man.
I'm sorry.
I'm sorry. So I mean, it's pick your poison. This kind of architecture takes a lot longer to get going than Rails. And when you're working in Rails with Active Record, everything that you need, now including WebSockets and background jobs, they're all right there in your backpack. So any particular feature you want to build, you can build it soup to nuts in the exact same project. You give that up when you go with a service-oriented architecture. And that is a little bit...
However, everybody with a Rails app in Austin doing any kind of significant staffing and hiring is now struggling to get into microservices. And they're effectively screwed. Like, I feel for you if you're in one of those companies. Because you really can't go from a monolith to SOA by extracting services. It's a complete rewrite.
It's an error, like the
worst thing, the worst thing you can do in the midst of a complete rewrite is also require your staff to learn
Elixir,
a new programming language. You're gonna learn a new architecture. You totally turn your head upside down away from relational database. From the tabular model to the event stream model. That's gonna be a mind-boggling, mind-blowing thing to begin with. And now you're gonna learn Erlang. It's like if it sounds like a game of how can we fail fast. And failing fast is great unless you're trying to succeed. It's a really, really dangerous thing to change your architecture and your programming language at the same time.
I like the ecto with the change sets. I mean, it's like an origami. You have to flip that inside out and stop thinking about change sets and start thinking about events. Like it's
you can't get event-oriented autonomous services out of something that started as an ORM. Because the only thing that you ever needed to do was to write events. And you can write events to a file. I mean, we've got some tech that makes it nice and makes it easy. The event store database is really impressive. It has some incredible features around event analysis. Like if you're doing trying to do fraud detection or pattern analysis, you do that. That's done off events. Drug interaction calculations are done off of events. Like this is all events. Your database, by the way, use Postgres and MySQL. They run on events. Like events are what everything works on. Everything else is just kind of like a shortcut. So when you stop taking the shortcuts, what we're kind of saying is, I think the reason why that most people aren't building applications in Ruby around events is that there's no tooling. Like you'll do something with tooling. You've got Rails, you'll use Rails. We've got Eventide. We're building out businesses on it. The tooling's there. Mind you, not documented. But anybody who really wants to try it out or even hack on stuff, like I said, we should spin off a study group, or let's get together at coffee houses. You want to talk about like service boundaries, all that stuff. That's just the kind of stuff we do.
I guess me, sorry. So like with microservices, like you can't pass information between services, right?
You're not supposed to.
Well,
Okay.
when you
Here's the great thing about microservices. Microservices are like SOA with the government warning labels erased. So microservices are a great way to get people into services by pretending that it's easy. It's just if you look at microservices as SOA services, yes, you're not allowed to query in real time information from another service, because that requires, if service A needs information from service B to do its business, service A needs service B to do its business, and service B has to be online for service A to work.
Right.
Like,
Okay, so-
you can't test service A
Right.
without service B.
So like, what are the typical relationships between services then, if they're not?
You
They're
can tell
none.
a service what to do. You can if a good example, you can tell the flight reservation system, I'd like to book a first class flight on this Austin to Phoenix, January 2nd.
Right, but you
Then they
can't
are
say,
gonna be passing that information.
Yes.
yeah,
Okay.
Yes, yeah, you
Yeah.
can, so information comes into the system through commands, but you don't, but that's a push system. Queries are a pull. You demand the other service surrender its data to you.
Like a consumer producer? Or is it, like, if I'm producing the event to service,
Right.
and from service A to service B, is service B just consuming it at that point, and then?
so that,
It's actually unlikely that service B should consume the events of service A.
Okay.
Well, there seems to be some relation though that, so like in the flight situation, if you go greater than 200, you get an error passed back. Like,
You don't.
It doesn't
So,
happen.
but there
So
are
how do you deal
replies
with that?
though.
yeah, you wouldn't get an error back, because that's synchronous.
Yeah, so
That's
you
all
have-
asynchronous.
You have replies, like if you want to, if you're doing a Venmo transaction, for example, and you want to send money to someone else, like the first thing you're gonna do is check and make sure the account balance is enough. Like I'm not gonna let you send $20 if there's only 15 in your account. So what I'm gonna say is like, is there enough money? And I'm gonna reply back saying like, funds held, or I'm gonna reply back saying funds not held. And I will respond to the event type, but there's no data in that event. It
Right,
doesn't
but
tell me
There's
what the
nothing in those
balance is.
messages
There
that
isn't-
didn't
It doesn't
show
tell me
up
I have $100
There
in
isn't
the
a,
account.
yeah,
It just tells me, can I do the operation I wanna do, yes or no?
there isn't a query, do I have money in my account? You just say, transfer the money, and a response message or event will be transferred or not transferred.
Yeah, that's specifically what I'm talking about.
Yeah.
Not transfer is.
It's a signal.
You have to build something to manage that.
Yes.
So you kind of have to know what the expectation on the other end is going to be. Like, even if it's so simple as true, false.
Yeah,
Right, and so that's
Yes.
that's the secret, is you do need that level of coupling. It's unavoidable.
Right.
You can't but not have a signal coming back.
That's
Right.
what
But
I'm
it
driving
must
at.
be as simple as possible, which means it doesn't contain additional information.
Okay.
Like, for example, if I say, yes, I will approve this $20 transfer, and by the way, the current account balance is $100.
Yeah, it's too.
I've now surrendered information.
Right.
And replies, like signals back from other services, are really just writing to the command stream. So commands, like anyone can write to a command stream. Like the account service does not own its command stream. Anyone can write to the command stream and say, deposit funds to this account, withdraw funds, transfer funds, whatever it is. You own your event stream.
So yeah,
And then so like when I'm replying back, I'm writing to their command stream saying like, this money was held, this money was deposited, this money
And
wasn't
you're just
deposited.
reading from the event stream?
so I want to disambiguate those. So it turns out that so we connect our services together over message queues. You
Right,
can
right.
use Kafka, you can use Amazon has one now. We happen to use Event Store because Event Store is so similar to something like Kafka, linearized messaging broker. We use it because we also use it as our event database, but it's not an event stream. So we end up with command messages being written to the Event Store database that we're also using for events. But yeah, services tell each other what to do over queues.
So if services aren't dependent on each other, and your Venmo transaction never responds back with that signal, what happens at that point? Do you respond back and process the event when that service comes back up, and you just give?
Yeah, it's a queue. So if that service is down, what happens is my process remains incomplete until it comes back up.
And then at that point, then I guess it would be more of a user interface.
Yep.
than-
Yeah.
Yep, then you got timeouts to deal with and
Yeah.
reliability to deal with,
So you said,
and
okay.
which you do with HTTP anyway.
Yeah.
Yeah.
But the
Well,
cool
it's probably HTTP at that point.
You can respond back to the user saying like, it's been transferred or whatever, or queued to transfer. And
Right.
It's
Yeah.
just sitting in the event stream waiting to be processed for when that service comes.
Yeah.
Which is how the availability, that's how the autonomous stuff, that's how the availability
So,
happens.
so by the way, when you build microservices that talk to each other synchronously over HTTP, what you end up having to do is rescue every possible like bad
HTTP
status
error.
code that you can get. With event sourcing and service autonomy, you have a queue that's stalled until the other
You can,
comes back.
yeah, but we're sort of making a presumption. You can also do this with HTTP.
Yes, you can.
It's just that everything over HTTP has to be considered allowed to not happen, right?
Right.
HTTP is built to fail, and so you can use it for things that it doesn't matter if they, like it, they used to say with Twitter, it doesn't matter if the tweet gets lost. It does matter when, like an X-ray machine gets to stop shooting the X-ray signal. So things that matter have to go over a more reliable mechanism.
So then what happens if your event doesn't publish? That's like, say my Venmo transaction, I'm like, I need to send $5, and it just doesn't publish, right? Like,
And you have a
is there ever
bug.
time that you can lose an event from that's happening?
No, because we don't really.
So like,
I mean, sure, if the database goes offline, if the event storage mechanism is offline, you're going to get an error.
Goes down, but like, there's no other.
But your processes will pick up where they left off when the database comes back
Right.
online. So everything that was written, like let's say the command message that was queued for initiate this transfer, when the database comes back online, your services will pick up where they left off. And that's the beautiful thing about event sourcing. When your system crashes, it comes back up. Every single event handler is idempotent by nature.
That's a big word.
That means that every single event handler can be reapplied. So we don't have to consider, have I already handled this message or not? It's completely.
You can rerun all the commands
Yeah.
without having any. You can rerun all the commands, but it doesn't cause the transfers to happen again.
Yeah.
Because we know.
We don't
We know that we've got
reprocess it.
events that resulted from those old commands, which means like you've got an entity state, which again is the state of a process. The process is a transfer. You can derive that through the events that the transfer has happened. So when a command comes in, you check if it needs to be executed. If it doesn't need to be executed, just exit, ignore it.
Yeah.
When it does need to be executed, it means it wasn't handled. That's where the crash happened. So you can start your service up and say, I know there was a crash. I know it was around Tuesday at some time. Let's back up about 1,000 commands and restart the service from there. All the commands that have already been executed aren't going to do anything new anyway. That's why anything with a side effect needs to be idempotent. Like when we've got services that send errors to AirBrake. Is it AirBrake? Raygun. We don't send them twice when we replay the commands. We've got to actually check the state of the entity. The entity is actually a state machine.
Well, yeah, our accounting system that handles deposits and withdrawals, we can start that entire service out all over again from the beginning of time, and everybody's account balance will be the same, even though we're reprocessing all of those deposits and all those withdrawals, all that account activity.
You reprocess them in the order that they were
Yep.
in the order that
Yeah.
they came in. So are you like, but you're only persisting them that one time, but when you restart that service, are you persisting them all again?
No.
It's just like
No.
No, because you can
No.
detect that they've
Yeah.
already been run.
Right.
They've already
You
been
detect that
executed.
they've already been handled.
If you write events, so the entities are always derived from event state. If you write the event twice or more, yeah, that's real data. Like if you wrote the deposit twice, that's 2 times that amount of money.
Right, but the tooling has features that allow you to build in you have to check for you have to check this stuff in your application code, and we have the means of doing so in the framework that are consistent and very easy to understand.
But it's effectively business logic.
Yeah.
Though. Like you know, you'll find a lot of tooling trying to be like only once messaging, and it's just a hellacious thing to try. Everybody has tried to move this into the transport. Everybody's tried to make a queue that guarantees once only messaging, and it's impossible to guarantee. So you have to put it in the business logic. You have to say, I've got this command, it'll result in such. What's the current state of the entity? Well, it looks like the entity has already seen this, so you just don't even do anything with it. You don't even need to reply. You know, when you're seeing a command, when a command gets processed that you can detect has already been processed, you don't even have to respond with status. It's just irrelevant. And also you can go through and clean up those commands. If you want to keep the commands for all time for audit purposes, you can. You can make them expire if you want and clean them out and garbage collect them after a certain amount of time.
It sounds like it's a little more than a queue then, like if it were,
Yeah.
if
Well,
it was like comparable to
yeah,
like an
it's-
easy stream, right? Like I'm streaming
Yes.
data in, and each I'm gonna pop off one by one off
Yeah.
each stream, right?
There's no, what is a queue but an event stream
Right.
that's persistent? I mean, an event stream is persistent. A queue can be
So these
ephemeral,
queues
but
you
there's
can-
no difference between a queue and an event stream.
You can push, but you can't pop really with these queues. You keep track of your position and you move forward one by one when you're consuming, but you don't pop things off
Right.
the
You
queue.
don't pop them, okay, that's what I was
Yep.
missing. So
You
as long
record
as-
your position, but and then for the command, when you're using the streams for commands, you can delete those old commands if you don't want to ever process them again or you want to restore the disk space. But that's outside the bounds of the
Unless you're
consumer.
using an immutable data store.
Well, you can still
Oh, no, you
delete.
can set
yeah,
timeouts
yeah.
on them. Yeah, you can set metadata as timeouts.
Yeah, time to live. You can say, I'm gonna enqueue this message and it's gonna be it's gonna exist for 7 days.
But you also don't need to use an event stream for commands. You could
You
use
Kafka.
Rabbit if you wanted to. It's not the right technology. I mean, RabbitMQ is about message brokering, which is a completely different set of patterns. So you see a lot of people trying to do microservices with RabbitMQ without realizing that RabbitMQ is not even intended for those problems. It's intended for integrating pieces of software that were disintegrated. It's EAI, Enterprise Application Integration. It's a completely different pattern. It's just that, hey, look, a queue, let's use it. But when you understand what Rabbit is for and how it fails, you'd probably want to go a different way.
This type of approach is really good too for over lossy network connections because you can you can broadcast those events to a remote client and it can project entities remotely on the device, and if the network goes down, the replication suspends, so all the information is stale, but when the network comes back up again, the replication resumes, the subscription resumes, and you can begin reconstituting the information again. So this is like a really neat way to do mobile clients as well when you have lossy networks.
Well, that's what Microsoft used to have sorry for bringing that up. They used to have a version of SQL Server that ran on mobile
Yeah.
and detected when it was offline, and then it would do database replication between databases, which is nothing more than log shipping, if you know that term from databases. And log shipping is event streaming.
Yep.
Like there's no matter what you do, you're not going to get away from the fact that there's event streaming happening in computers. Probably. There's no way to do replication without event streaming.
Yeah.
I mean,
with mobile.
Yeah.
oh yeah.
Yeah, that's
Yeah.
why they have Pouch TV or whatever. There's the mobile thing. Yeah.
We have 5 more minutes.
Yeah, we
Sweet.
did it.
We did it.
Clean this up.
So
Question. So when Kelsey was talking, and I was a little bit distracted, putting out the fires under the thing so they didn't burn up. But it sounded a little bit like they
literally putting out fires.
literally putting out under the food.
Yeah.
And I was like,
Yeah,
Yeah.
yeah. Datomic's got a different use case though.
and then I heard him talking about Event Store, so I looked up geteventstore.com.
Mhm.
That's what you were using?
Yeah.
Yeah.
The Get Event Store?
It works really well. The documentation has been great, but I think it's pretty good.
And we started when it was in a rather beta state, and that was painful. Now I think ironically, the people who make Datomic originally approached the Event Store people for that code base. The thing about Datomic is it's just a different use case, and the purpose is to write the back end. Datomic works on another back end like Cassandra, so it's really a front end for event sourcing, and it actually feels a little bit more like Kafka, it's really very good for front end ingest stuff, but Datomic is also good for data analysis because it's working off of a long-term store like Cassandra. So they're similar, but the features in Event Store are really for the Event Store database are for writing event-sourced applications. I know for sure Kafka did not start that way, and it's not really that easy to write event-sourced applications on Kafka. Datomic is slightly different as well because they had a different set of ideas hit, but yeah, there's
Also, don't use Redis. I'm just gonna say that right now. Don't do it.
And like I said, we're basically taking the bottom layer of our app of the stack and replacing it with or augmenting, supplementing it with Postgres.
So, yeah, eventually I wanna
so
support those.
that everybody can use it without installing and running a new database. And then we're going to go back and rewrite it for Get Event Store.
All right.
Cool. You mentioned Udi Dahan and hearing Greg Young in there and all that. Do you have a part of like the CQRS?
Yeah. CQRS is where is inherent, and that pattern is command query responsibility segregation, and it really means what it boils down to is kind of the stuff that Nathan and I touched on. There is a database for reading and displaying data. So CQRS basically says there's commands and there's queries. Commands go into one database and queries come from another. Don't try to do it on the same database, or you're basically gonna have to compromise. You have to make too many compromises. And those compromises end up in systems not being able to be broken up into services, and teams getting slower and slower due to the coupling and model objects. So if you have one data store, which is event-oriented, and that's where you write things to, and then you got a backplane that's basically saying, take these events, make relational tables, and you read from that, that's the separation between commands and queries at the architectural level. It also means don't ever read when you're reading, never modify. So that's really the original meaning of it. But as it gets like propagated into the world of service design, CQRS comes to mean we are going to recognize that we have two different forms of databases. One for reading, and it's message-oriented or event-oriented, and one for writing, which is our transactional stuff, and one for reading, which is for the display stuff. And when we separate that stuff out, it's amazing how simple it becomes if you get it well and get it right to build web apps. Because you want to paint some stuff on the screen. It's not a matter of like doing some active record AREL thing with joining this. It's like put all the data you need in one row. If you want to test that, write that data into one row and then paint it on the screen and see how it works.
The UI engineer that does JavaScript and HTML, CSS, they don't have to like download your stack, get Foreman spun up and all this stuff. You just give them a read database and the basic front end kit, and they can go to town. It's pretty cool.
Yeah, a read database. The idea is, and this is. I mean, I don't, if you ever come across Cassandra, this is the fundamental design principle around Cassandra is you structure the row for the query you're going to do, and then you figure out how to get that data into that row as a matter of the service architecture. But joining and stuff like that, we tend to eschew it, at least at that scale.
All right.
You know, Twitter, when Twitter used to fail, it failed because it was on a database that required joins and locks. Like that's why it went down. So that couldn't work anymore. Like if you understand, I think Kelsey was going to mention this, but the way Twitter is architected, your timeline isn't a bunch of joins between all the people you follow. Your timeline is pre-computed in one row, or one row. So you pull up your timeline, all those tweets, all those tweets are already there. It's just we're doing one read off of I think it's still Cassandra, but it does one read or one row. When a tweet comes in, they find out who all the followers are, and they duplicate that tweet to all the timelines. So there's no read time performance problem. It also doesn't take the database down like it used to.
Yeah, the storage costs are probably a lot higher.
Yeah, the storage costs are way higher.
Like Justin Bieber tweets.
That's why we're also selling storage.
So Nathan, that's actually why I didn't bring it up, because before I did the example, I did a lot more research into it, and because of like celebrity followers, like Justin Bieber and your Lady Gagas and all that, they don't write those to everyone's individual streams, it would be too much. Those are joined at runtime, but there's a separation made between people that have like a certain number of followers and people who don't, to like differentiate the story. So I was like, I didn't want to get into that, so I didn't bring it up.
For the most part, it's true.
Yeah. Well, I figured like I didn't want someone to be like, well, actually, like,
You know the troubles.
If your Twitter account has most unchecked.
I worked at People Admin.
Bypass is great. Well, something.
Yeah, so now I get
Some reporting stuff that I like, so. Can't take much.
Good.
I should get coffee sometime. I'd love to go over this stuff a lot more in depth.
I'll get a friend to make good.
Yeah, I make myself available and chat about it.
consultancy on events.
We're on Twitter.
Yeah.
My Twitter account.
Yeah, I got it.
If it's something, our goal with hiring, and his goal with hiring is to hire people that we already know.
So
It's out. We're done. It's not documented. I mean, it's out. It's open source.
And like he said, like we're all open to
We've got
chatting about it. And like when we are hiring, like we would like to have people
that doesn't believe it.
do it. Like from as opposed
So that's
to
gonna start happening. We're doing
the person that we just hired was.
a workshop.
CQRS, the command, doesn't return, right? The official story does not return. So we were running into,
We need to just start writing it.
with this proof of concept of like just a simple example of like this banking app. You know,
Yeah, so I mean, I
Kind of. Well, I read the same for everyone.
or you transfer money or whatever.
It's been,
You know, with a
the
typical
people
web
who are
app,
like really into
normally what
it,
happens is you make that deposit and then it'll go show you like, here's the page with the finished product, like you're so it happens, you know. But what you need for that is an ID, and not only is it not returning
Are you generating client side UI? You have to be generating client side. So you have to pass a unit
absolutely, I
in.
think, but I think we need
If you're not doing that, nothing will work.
some understanding of how the.
You will probably, you would be stuck indefinitely if you were still trying to use server side.
Exactly. Okay. Well, that answers that question, because that's basically what we're getting into of like.
Auto increment IDs, like, I should have mentioned this at the beginning. Auto increment IDs and services are like oil and water. You cannot build services with database generated. You'll never be able to load. You'll create a resource. You'll never be able to locate it.
Exactly. And that was what we were running into, like this doesn't work.
Yeah, it doesn't work. Yeah, that's pretty much.
Basically, randomly generated ID.
Yeah, you would. Yeah, you would like. You would chip the root. There's a you would generator. Hex, secure random, hex digest or whatever it is.
And my second question was the event time repo in the whatever that is, the Obsidian BTC. There wasn't anything in it.
Oh no! We had moved it to the event type project. So it's all been moved. So it's a separate organization. So hit me up on Twitter or something, and then I'll send you a link to the new project.
Awesome. I will. Cool, man. Thank you.
Yeah.
Hey, so Obsidian Company?
Yes.
Yes, hi.
Unless
my
you
name's
work
Doug.
outside the
Hey, Doug.
Hey, Nathan. Are you hiring?
Not currently, no. We're kind of growing
I mean,
slowly.
you work outside the office.
Yeah, if that changes, we'll make a big announcement.
What time?
Is it, what's the website?
Okay.
Well, actually, the product that we build is called BitPeso, and so the website's all in Spanish. So we're basically building all the backend systems. But it's not like a typical American startup where it's like, here's the website with the press, frequently asked questions, careers, and blah. Like, doesn't work that way.
It's usually don't.
Yeah.
Well, that's cool. That was a cool talk.
Thank you.
It was a lot.
You wanna go for beer?
Yeah, let's do it.
It reminded me of like game server program.
Yeah.
I don't know if you've ever done any of that.
I've never done it, but it's the same problem. You have an extremely like latency sensitive distributed system. That's a video game. I've been playing Overwatch recently. It's like amazing the rubber banding they have to do to like coordinate.
Client-side prediction.
Yeah, it's crazy.
That's why I said
Oh, really?
command.
I was his last name. I was his
Once
last
I was
name.
making a game, and you know, if you like
They assigned him playing.
have enemies you're sending
Assigned someone.
commands to, you gotta put them in an object and they just send them as like functions. If you're sending over the network.
Yeah, it's really. I would imagine that video games, like networked video games, discovered event sources well before enterprise software ever did.
The first thing that became microservices is
Well, cool talk. Nice meeting you.
she was like flying in
Nathan and I still both work at the same Scott. He's actually doing an independent pharmacy around So when he did work in the city, it was all underneath the like event was underneath the framework of our company. So it's actually moved out to a project now. So that's what he's trying to build it out.
I
hear people talking about this stuff.
I love, like, I feel happy when I get to go to work, like, I don't have to use Rails. I mean, we have a Rails front-end service, but it's like, it's not all that bad to use Rails as a front-end, like, just in queuing commands and querying the read model.
We just hired a React. Like that's all of us are back.
You gotta have a front, so front end is not like Ember JavaScript. Front end is the entire interface to your web interface, right? So that includes your, let's say, Rails web server and its endpoints and your clients. Like all of that is one big concern. So your web front end server, you know, when you make a post request to it, you write a command, it's just one of the backends. When you do a query to get to paint the web page, it'll fetch data from a read model and spit it out on the page. But it's not active, it's not an ORM.
So it's not like
I mean, is there even, do you guys even have a model?
or is everything?
Well, we had some initial prototyping code that's still there, but basically no, we don't have that. What you do is you ship all of your services, you'll end up shipping a client library like a Ruby gem. Think of it like the S3 Ruby gem, where you have a client that just kind of makes it easy to interact with the service. So your Rails app will depend on all your client libraries as gems, and it'll use those client libraries as queue commands. That way you have kind of a nice little interface for every one of your services. And it'll have the schemas for those data structures. The messages have data structures, they have shape, attributes, and types. So those are defined by in the client library and disseminate.
I like
That's for
That's for publishing commands. There's another service running in the back end that is subscribing to all the event streams and projecting it into a data, a Postgres database. And that Postgres database we can just read directly from Rails.
It's like trying to do like this transition from projection.
It is not. In other words, it's not a source of truth. It's a representation. It's an eventually consistent representation of your data, which is exactly what you need to paint a web page.
We were doing legacy code in our company.
So, is there any reason that gem definitions?
Yeah, that happens, right? But we're not like trying to
Yeah, services.
and like
If a service uses the account service, it'll use the client library to issue deposits as well. So the services will when a service depends on another service, in other words, it tells it what to do, doesn't ask for anything. It uses the client library for that service it wants to depend on to issue commands. And that makes it, you end up with methods where the required arguments map to fields in the data structure. So that you have that nice method binding. That's kind of what you want to make sure you've got it right.
The 4-year-old that was still in
Validation. Yeah, your client libraries will tell you what you did wrong or anything, so you can think validation errors on a web page.
But I can't wait to
So,
do it again.
do you have any tips on where to start?
Yeah,
Because like the easy place to start with like Rails
we can have
MVC
no
and
reach
your
out or
based app
something,
is
yeah.
to figure out what your entities are, what their attributes are, right?
So what you have to do, there's a technique called event storming, which I haven't learned too much before. It's becoming popular. You put different events of the system on sticky notes and you kind of arrange them together in clusters that become your services. But basically, it's just like folding an origami inside out. Instead of thinking about the data and the relationships of the data, you think in terms of outside in from the user interactions. What's the user doing? They're booking a flight. What information do they need to book a flight? They just need to know the origin city, the destination city, and the time of day. And then you percolate that through the process of turning that into a reified reservation. So you kind of think about the business process. That's what you model. You don't model entity.
Okay.
The entity is just a view into the state of the system at a point in time. The process is what you model.
I actually need to get my hands on at some point when I get really closer to saying
It's not even
pretty much
like, and even like the two of them have
How are you
I
actually
kind
getting,
of
what
like
does the
large
system
like documentation, bug fixes,
These are
like
gonna
small
find
feature edition.
How is
Right.
Yeah, yeah. But yeah, it's we're getting close.
not
to
even
that.
back out.
But yeah.
So you're sort of looking for verbs, right? I mean, you're looking for we schedule flights, or
Yeah.
we sort of arrange flights.
That's a
we
good starting
opt
point.
to
Yeah, that's a good. You think in terms of verbs. Not that you avoid nouns. It's not that absolute. But the constraint of services are not allowed to query other services will guide you towards the shape of those service properties. Like it really does that nicely. Because you start to realize like, well, if I draw the boundaries this way, then all the data is not where I need it. So you start to think, well, what is the bare bones necessary to book a flight? And that's all you want that service to see. And that information is now authoritative in that service. This reservation is for Scott at 10 p.m. Red Eye flight from Austin to Phoenix next Monday. That's that reservation. That's the only location in our entire system where that information is authoritative, where you can make a decision based on that information.
So, I mean, really, it would just be it's Scott and it's flight number 297. And we don't need to know anything, right? It's just flight number 297.
Yeah, sure. I mean, this is how it grows. You have flight 927. Actually, I don't know if you've read much about lambda architecture, but there's a lot of similarities between lambda architecture and cluster.
Yeah, thank you.
The idea of having hot and cold storage and the way that that's modeled. Here's where your processing happens. Your processing needs hot data. There's a lot of, I think there's a lot of similarities.
It has some operations. And they don't have it. So it's not really how it's
Yeah,
but it can.
got a lot of.
If you just put the data model
Store that ground truth, and everything else is just projection
Yeah.
on top of that. And your ground truth is there's a bit.
It's really difficult to do those things because it requires
Yeah, it's pretty cool. I mean, the thing is, like, it's hard, it takes a lot of work, and you will feel lost, and you will backslide into the canonical model many times. And that's why you have to hold fast to the constraint, because it'll be real tempting, because it's hard to even, you can't build a feature soup to nuts in one context anymore. You have to build flight booking soup to nuts as one small process that's isolated. So it takes a maturity as a programmer. Like, this is not for, like when you're new to programming or you're new to the style, you have to have a mentor, I think, that's able to walk you through this.
Capable of just creating streams that are effectively
The thing with ideas now is just tons of time. Wasted tons of time. Like me and this idea, wasted tons of time on it.
Yeah.
It just wasn't.
Yeah. This is, it's one of those things that you've done the auto increment ID for so many years. It's just the way it's done. Yeah. But you have to be prepared to question it.
And I guess that's what we're using.
And I think that's the real genius of service-oriented architecture, the genius that's necessary is the ability to have an open mind about different ways of solving problems. Because it all is going to look and feel different.
Yeah. So another question that just popped into my mind. What if you have a failure? You've got your UID, but it fails, so that UID doesn't get it?
No. If there's a process and that process fails midstream, you've got a stream for that UID. Okay, there is an entity that failed, and you have to model failure. You can't not model failure. If the booking was declined because we overbooked, then you record, a booking declined or not booked.
Okay.
And then,
Under that.
right. And the cool thing is modeling failure becomes really easy. It becomes more like functional style, like a functional programming language. Okay. I'll get us out of here.
Yeah, I wish we were already there. Such good ideas passing the scene. Because like I said,
Yeah, so
it doesn't require
This concept is going to be, it's been a while
You want to know what you're supposed to keep track of, or you get to next year and you're going to track, you're going to lose expenses and everything.
Yeah, that sounds good. Expensive. I appreciate it.
Yes. You know what, I just started using the app called TripLock,
more chairs for them to bring out.